Today we will talk about compile time, factorial evaluation in C++. This is the traditional way to write a factorial using recursion. It's very simple. The function is taking an argument and then calling itself recursively with n-1 as the argument. And then we have a base condition here which returns back 1 as the answer, and then all the stacks return back and then we get the answer. This is very simple and this is the traditional way to do things. This can also be done iteratively, but the idea here is that how we can do this at compile time, not at runtime. The difference why it matters is that we effectively can think that the build times are free to us, that once it's built, it's in the exe, we do not have to pay any longer across invocations or the runs. So it's one-time payment for price, and as opposed to runtime when you will have to pay it on every run. So this is the counterpart which is in compile time. So compile time employs templates in C++ to do it. So look at this class template, which is dependent on another class template. So it has an parameter t and it's dependent on another class template with t-1 as the parameter. We also have an full specialization for the same class template when the parameter is 0. The important thing in C++ is that statics and enums are evaluated at compile time. So when this statement is to be evaluated by the compiler, it has to do all the work at compile time itself to find the value. So what happens in this case is the 5 will generate the class template for 4, 4 for 3, 3 for 2, 2 for 1, but 1 already has the answer for 0. So effectively what has happened is that we have found the answer for 5 at build time itself, and it's something which is in your exe. So we effectively, when we run this, we are paying no price because it's already, the hard work has already been done by the compiler. So there are pros and cons to both the approaches that we talked about today. The traditional way to do things, compiler is not doing any additional work for you, so build times might be faster. In this case, the build time could be a little longer. It could be a little more heavier because you have generated more class templates. But the advantage is that we are no longer paying the price at runtime. We already have that work done by the compiler. It's already in our exe. This was originally shown to the C++ committee way back in 1994 by Erwin Unruh, when he showed that how class templates can be used to generate or show prime numbers. We will have another video on how we can do the C++ metaprogramming. It's essentially metaprogramming for prime numbers also. I hope you guys understood as to how class templates and full specialization can be used to effectively mimic recursion in this case. If you've liked this video, then please like, comment and subscribe, and looking forward to talking about the prime number generation in another video. Thank you.